Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hi guys, welcome to a brand new episode of the Clear to Send podcast. This is Francois, your host, and today we're here to talk about Wi-Fi security and where does Wi-Fi security stand in 2019. And to do so, we have a guest to help us understand a little bit the different updates that came to Wi-Fi security lately. And his name is Hendrik Lüth. He's from Germany. Hi Hendrik, how are you?
Hi, good morning, Francois. I'm fine.
Yeah, very, very happy to have you on the show. We've been trying to schedule this episode for quite a bit now, and I'm happy we'll able to make it happen. So you live in Germany. Do you mind presenting yourself a little bit to the audience, telling us, what you do, where you work, and how you got started with Wi-Fi too?
I work as a system engineer for a company called CANCOM. We're a system integrator, and what we do is like everything with IT, but I in person implement Wi-Fi networks and network access control solutions. And I'm based in Karlsruhe, which is about 1 hour south of Frankfurt. I guess most people know Frankfurt because of the airport.
Yeah.
But so this is what I do. And I got started with Wi-Fi in, I think it was 2013, because back then we started a public Wi-Fi project with open source software in my hometown. And then I got used to Wi-Fi a bit and started looking into that, but it was not that deep. And then I started university, and I started working at the university's Wi-Fi team, and there I got into the Wi-Fi field really deep, and now I work with Wi-Fi. So
that's awesome. So how did the public Wi-Fi with open source software work out?
So basically, the concept of that, the project is called WiFi, which means like free radio. And what the project is about is to offer free Wi-Fi and to the people, because in Germany we have laws in place which forced us to run captive portals and to limit the access to public networks. So public Wi-Fi hotspots are really rare in Germany.
Okay.
And the project's goal was to set up a mesh network which allows people to open their internet access to other people by tunneling the data through VPNs to a central server and then to some servers somewhere on the globe, and to work around this law in Germany. And so the whole network was based with OpenWRT boxes, and they were all connecting with a mesh network. So it was a high available network built for internet access and learning about all those technical stuff.
That's interesting. Did it work out pretty well, or?
It works pretty well.
Okay.
In Germany, the largest networks with that, they're all non-profit, and the largest networks run with, I think, 1,500 nodes in the network, which is pretty large because the protocol they used was written for about 30 mesh nodes. So 1,500 is quite a lot for that. Doesn't scale that well.
Yeah.
But they also started to become ISPs. They registered with RIPE, and all now have peerings at D6 and other internet exchanges. So that escalated a bit.
Yeah. Okay, that's interesting. So, talking about Wi-Fi security, when did you get when did you start to get very interested in Wi-Fi security? Was it when you were working for the university, or a little bit afterwards?
Yes, that was after Matti van Hoof released his attack against WPA2
Okay.
So
The crack attack?
Yeah, the crack attack. That was when it started, because I was on the Wi-Fi team, and they released crack, and then it was like, okay, we have a meeting with all the important people tomorrow. We need someone to present that. And I was like, I have totally no idea what I'm doing. And they were like, okay, you have until tomorrow. And I was like, okay, let's try this. And yeah, that's when it started. And then I looked into that a bit more after I started working at CANCOM. And yeah, because you need to look into Wi-Fi security if you want to present security solutions to your customer. So and if you want to implement that in a good way, you need to understand what's happening.
Okay. And so you did a presentation or a talk. You gave a talk for a conference in Germany related to Wi-Fi security.
Yes.
And we included a link to your presentation. It got recorded. It's only in German, but for the German audience, you guys can go and watch the presentation.
Yeah, maybe they will release subtitles, but I'm not quite sure.
Yeah.
The CCC always tries to release English subtitles, but it takes some time to go through all of the conference talks.
Are you planning on attending WPC Europe this year?
I'm not quite sure. I have to look, because I already have like 2 or 3 conferences, including one in United States this year. So I need to ask my company whether I'm allowed to go there.
Okay.
But yeah, we'll see. I'll be, for the German people, I'll be in Munich on the 6th of June to the EKH Wi-Fi Design Day. So
awesome. Oh, that's
cool. If this episode gets released before that, they can hear that.
Yeah, we'll see. Probably we'll try to make it happen. Okay, so to start the discussion around Wi-Fi security, why don't we talk about how Wi-Fi security was last year before all the changes? Yeah,
before all the changes, we've been in the 2018 status of that Wi-Fi security. The latest thing we had was WPA2. And yeah, well, until WPA2, there was a lot of stuff happening. So we won't go into that in detail, I think. There is a really fancy security timeline. I think it was done by you. So you can probably link that one. I really like that. It shows everything. It's really detailed, and it's real good. And so we had WPA2, we had the crack attack, and then something was about to happen. So the Wi-Fi Alliance announced that they are working on WPA3. And that's what happened now, and what's now state of the art. So WPA2 was widely supported and was used like everywhere, but it had some issues because, for example, WPA2 Enterprise for larger enterprise networks is not a decent solution if you want to run a home network or a guest network, because even for experienced users, setting up a connection to a WPA2 enterprise network is sometimes too complicated, and if you do it wrong, you can cause more security issues than you fix with that. And also, we had the normal open networks, which are just open and unsecured. So you had to hope that the people have end-to-end security in place. And we had a large growing amount of headless IoT devices. And they normally only support WPA2 PSK. And also that's because of their hardware limitations, because if you want to do 802.1x, you need a decent amount of computing power, and all those small tiny chipsets don't have that in there because it's also expensive. And so there was something that was needed to happen. And during the last years, the vendors came around with different solutions how to tackle all of those problems.
Yeah, what's surprising to me is even when I created the first version of the security timeline you mentioned, I think it was back maybe 3-4 years ago, and WPA2 got introduced in 2004, which is like, ages ago. If you look at how the
15
Wi-Fi
years
protocol,
now.
15 years. Like, if you look at how the Wi-Fi protocol has evolved over the years, it just seems like a very long time without any improvement to the overall security solution. And like you mentioned, it's not very easy to implement WPA2 Enterprise. And then we have these large amount of IoT devices that we want to, secure on the network, because we know they can also be a security breach for our companies. So we have new needs. We needed a security update, and I guess the Wi-Fi Alliance, worked on that. The only thing I found complex or hard to understand is, they didn't just come up with WPA3. They came up with different certification programs. So maybe we can just go over them with you during the episode. So just to make it a little bit clear for everyone to understand what's behind this WPA3 thing, because I think it's still a lot of it is still theory for a lot of people. If you go in the wild right now, you won't see a lot of WPA3 implemented. But it's important for us Wi-Fi engineers to understand it, because it's going to come in the future, and we're going to start implementing it very soon, I think.
Yeah.
Okay.
So because 14 years is quite a time for a security standard. It's like centuries. In security terms, it's centuries.
Yeah.
And so they didn't do nothing. And the vendors started implementing solutions around that to mitigate those issues with WPA2. For example, if you steal the key of a WPA2 network, for example, if you have a coffee shop and they say we want security on our network, we don't want anyone to connect to the network, and they write down the password onto a chalkboard on the wall. This still allows people to run attacks against those networks. And because if you have the key, if you know the password of a WPA2 PSK network, you can decrypt all the data by capturing the four-way handshake. And so this is also applicable to IoT devices. So if we have hundreds of IoT devices in a network of thousands and all use the same password, if one gets compromised, all of the communication in the network is lost, and not lost, but decryptable. And we need to change the password on all of the devices. And to mitigate around those issues, the vendors thought of a solution where you can use different passwords inside of one WPA2 PSK network. And so let's look at the four-way handshake again for a short time before we look into those multi-password solutions, because the four-way handshake is quite easy, because the AP starts and sends his anons to the client, and they both have the password, and the client can now calculate the PTK, sends back his SNONs and a message integrity code, then the AP calculates its PTK, and then it sends back his message integrity code and a GTK and gets an ACK from the client. So that's the whole process. And if we look into those solutions, I found 3 different implemented solutions. And the first one is, I think, the oldest one, which is from Arrowhive. It's called PPSK, or Personal PSK. And basically what they do is that they guess the password the client is using, because the well-known function to calculate the MIC is on both sides. So, and they don't use any big magic in that. So if you have the anons and the snons and the message integrity code and the MAC address of the client, you can calculate on the AP side if you know, have also a list of all the passwords which are allowed on the to connect to the network, and with all the information you get from the four-way handshake, you can simply run through all of the passwords and calculate the MIC you expect from the client, and then you can say like, okay, I received this S-nonce from the client. I sent this A-nonce. The client's MAC address is this. So this is the list of my passwords, and the MIC matches with this password. So I'm going to use this password for the future with the connection for this client, which is basically they take the four-way handshake, abuse it a bit, and it works. The problem is now with all of the vendors that they normally try to patent their solutions, which causes us now that we need for the other vendors a different solution, because the easy way is already used by PPSK with Echo, not with Aerohive.
It's not something that's standardized. Yeah. That's what you're saying, right?
Yes, it's not standardized. And so Ruckus came up with their solution, which is called Dyn PSK, and they use one PSK per MAC address. So you can add that information into the zone director. They have an internal database in that, and they can also do some kind of auto detection. So you don't need to know the MAC address of the client before the connection starts. So what they're gonna do is probably the same thing like Aerohive does, but they only do it once. So I think that somehow helps them to mitigate this licensing or patent issue. And the third thing I found was by Aruba. They do something called MPSK. So it's like all
multiple
different named.
Multiple PSK,
and what Aruba does is they do a MAC authentication in the background, and then they return a special VSA which includes the password. So you can based on different rules, you can in your radio server you can return the password.
You need ClearPass for that?
No, we don't need ClearPass for that. You can do it with every radio server. You just need to throw in the VSA for that. So
that's what Aruba tells you, but I guess you can use any.
Yeah, it's like, you can. Well, it's easier with ClearPass, but
you just
if you already have large radio servers set up, and I migrated radio servers, so it takes sometimes it takes ages.
Yeah.
It feels like ages to migrate to a new radio server. So yeah.
So all these PSK solutions. So I should say all these proprietary PSK solutions. They aim to fix WPA2 personal, right? Or to give it more flexibility.
Yes. Both of that. So you try to fix the problem that you can decrypt all the data if you know the password, and it also fixes the problem that you have to re-provision all of the devices after you've set up the network and maybe the password gets compromised. So I think there are some solutions from other vendors, but I'm not that familiar with the other vendors. So do you know some?
Yeah, Cisco has something called Identity PSK. Which is pretty much the same thing. So you could have individual pre-share key per devices to authenticate the people on the WPA2 personal network. I found those solutions very nice. Like you said, it's very flexible. You can pretty much, if someone leaves the network, you can just remove their password. Everyone can have a password, and it's just easy for the user because they're used to connect to a WPA personal network. They do it at home, so it's easy for them to just get used to it, and you provide a little bit more security. It's a little bit more work in the background because you have to create the passwords, make sure they get distributed properly. But it's a nice solution if you want to add an easy layer of security on your network, I think.
Yeah. So, but still, it's all of those solutions are really good. I mean, like they solve a problem we had, but it's from a security perspective, that's still just a small workaround. So that was something that needed to happen.
And also, it's not standardized.
Yes, that's the other thing.
Yeah. So you cannot expect it to be widely, used and implemented and deployed.
Yeah. Well, the good thing with that solution is that from a client's perspective, it still looks like a normal WPA2 PSK network. Yeah. So it's just background work on the on your system. But if you use, for example, if you have like a large network and you use different vendors in that network, you can't use the same solution for everywhere, because you have one solution in one place, then you have another solution in the other place, because you run different vendors on your network. And yes, you can have it like with areas, like on one campus you have like Cisco, then you can use Cisco solution there. On the other campus you have Ruckus, on the other Arrowhive, and the other Aruba. And so this is problem. Like, like all solutions which are not standardized are problems, because we need to standardize all the solutions. And so then now at this point, something needed to happen, and it happened, and the Wi-Fi Alliance created WPA3.
Hello, this is Francois, your co-host. Did you know that I am also the owner of a Wi-Fi company called Semfire Networks? When I talk to my customers, they are often telling me that the users are complaining about the quality of the Wi-Fi. They would like to improve it, but are not always too sure where to start. And this is where we can help. At Semfire Networks, our focus is the end user experience. We want our customers to receive amazing feedbacks on how awesome their Wi-Fi is. So we provide professional services in order to help our customers making the best out of their current or future Wi-Fi infrastructure. We guide them at any step of the Wi-Fi network lifecycle by providing services such as Wi-Fi design, site surveys, deployment, Wi-Fi troubleshooting, Wi-Fi audit and optimization, as well as Wi-Fi training. Our expertise allows us to help our customers provide a reliable Wi-Fi experience, even in difficult environments such as industrial facilities, large hospitals, or crowded convention centers, to name a few. So if you'd like to learn more about how we could help you achieve better Wi-Fi, please visit our website at semfirenetworks.com. Feel free to also send us an email if you want to get in touch with us. Our email address is hello@semfirenetworks.com. That's hello, HELLO, at semfio, SEMFIO, networks.com. Thank you. Okay, so WPA3 is the new big, certification from the Wi-Fi Alliance. Sorry. So what's behind WPA3, right?
Yeah, well, in the beginning they announced a lot of stuff they wanted to do into WPA3, and after they released the actual program for the certification, that it got a bit downgraded, and so we need to separate that, because there's WPA3 now, and there's something called Enhanced Open, but we'll get to that later. Inside WPA3, we have SAE, which is translated Secure Authentication of Equals, which includes the Dragonfly handshake, which is a new handshake to exchange passwords, and also they added WPA3 Enterprise, which comes with stronger cryptography and some special cipher suits to match government requirements. So, but starting with SAE, we have the Dragonfly handshake, which is written down in RFC 7664. So if someone wants to read that, it's actually quite nice to read, but includes a lot of math.
Just like any cryptography.
yeah, that was the main issue for me when I when I started Wi-Fi security, because I'm really, really bad with math. So like for me, 1 and 1 is 3. So
so now you understand what you did math in high school, right? It's like, damn, now I know.
Yeah, no, not really, because I probably need to study math or computer science to understand that, but I didn't. So yeah.
Okay.
Well,
yeah. So I guess I didn't do the same math as you then.
Yeah, it's just like it's complicated. And SAE is actually not that new, because it was introduced, I think, with 11S for mesh networks, because the protocol itself was designed for mesh networks. If someone wants to read up, that's subclause 12.4 in 802.11 2016. There it's described how SAE works. They call it authentication using a password, which is like totally underrepresented for SAE, I think. And SAE was designed for mesh networks, so there is no initiator in the protocol. Both sides can start the handshake. So because in a mesh network there is no real role which can start that. So with the with bringing that to the clients, both sides can initiate the handshake, but normally the client will, for example, the user's devices will start the handshake, because why should the AP start the handshake with a client device? Because the AP doesn't know the client device wants to connect. So, and but from the design itself, both sides can start this handshake. So this is called this is not called a lockstep protocol, because in a lockstep protocol you would have one side to start, then the other to answer, then the other side to start, and then the other side again to answer. So you have these steps which are pretty hard limited defined. So this and SAE is the opposite of that. It's not a lockstep protocol. So I haven't found the opposite of that. So I just can say
it's unlock step protocol.
Unlock step.
Or free. It's a free step protocol.
Sounds insecure.
So from a security standpoint, it's more secure to have a protocol like that. That's not, that doesn't have lock steps.
Yeah, I don't know how to call it. I think I need to talk to some experts.
So is it more secure because it's less predictable?
Yes. So why is SAE secure? There are two things. Because it's secure against the offline dictionary attacks. So a dictionary attack is when you go through a list of possible passwords, and then you try to connect to the network or decrypt the data you gathered. So, and even if you know the password, and you do it offline, like for example, you sniff the Wi-Fi traffic, then you upload everything to AWS and start calculating. Even then, you're not able to retrieve the password, and you're also not able to retrieve and decrypt the data from the client. So because they use, at one point in the handshake, they use random values, and those random values cause the actual key that is used to decrypt the data to be different with every client that is connected.
Okay.
At every time the client connects. So even if you have the client connected to the network on day 1, and then the client connects to the network at day 2, and you gather data from both days, you're not able to decrypt the data just because you have like different captures from different days. And also the protocol itself is secure against active and passive attacks. So you cannot go there and just simply start running, try to get into the network. And even if you're into the network and you know the password of the network, it's also not possible to decrypt the data you capture from other clients, because you still have those random values which are in place, which are per client, and this helps a lot with the security.
Okay.
So
yeah.
So what's in there is this Dragonfly handshake, and this Dragonfly handshake consists of a frame exchange of 4 frames. We have we use the authentication. So after the probe request and response, we use the authentication frames to piggyback the information we need for the cryptography. So the first thing is we exchange a commit message, which contains the finite field cryptography or elliptic curve cryptography group. So which is basically a curve where you can use for the cryptography, or it uses some values where to start on that curve, and so they just exchange that. They also exchange a commit scala, which basically is a random number with some magic in addition. So you don't have the direct the random number itself in the air. And then there is the commit element, which is like, basically it's a hash of the, not really a hash, but it's something mixed together with the password, the random number, and all of that is thrown against the finite field or the elliptic curve. And then there's a lot of magic happening. I'm not going into that in detail because math again. So every time I mention magic, it basically means math. But so and that's what's transferred. So and then both sides, what they basically can now do, or what you can basically do with elliptic curve cryptography is that you can exchange a point on the curve and the curve itself with each other over an unsecured channel. So even if you gather all that information, you cannot calculate what's happening in the end. So, and with all the information exchanged, we can add a picture to the show notes in the end where I can that I created, where we can where the people can actually see what I'm talking about. And so, with all that stuff happening, both sides can calculate a secret which is strong enough without sending the password itself over that unsecured channel. And after that, they exchange a confirm message, which is simply includes confirm element, which is like, again, a hash that includes that shows the other side that they interpreted the data right and did the calculation in a right way. So, and after that, they do simply association, and then they do a 4-way handshake again. So the 4-way handshake is not dead yet.
So so you have the SAE handshake right before the association, so association request, yes. Association response, and then after that you still have your 4-way handshake.
Yes, because with SAE they started something that they have that the well-known functions on both ends of the handshake. They created them in a way that they can use like any password, even with one character. Okay. And the password will still generate a cryptographical strong value to use with the 4-way handshake. So all of the you could compare it to the password in WPA2, but all of the cryptographic secrets that are used for the 4-way handshake, all of them are the same size and they are equally strong regarding the cryptography.
Okay. So they use the SAE handshake to derive the PMK, and then they use the 4-way handshake to derive the PTK.
Yes.
Okay.
That's correct.
And then for the SAE handshake, do you know what type of frames are used? Are they leveraging the authentication frames?
Yes, they are leveraging the authentication frames. So all that information is piggybacked on those. Actually, in the whole of WPA3 and Enhanced Open, they really like to piggyback data to already existing frames.
Which is good. I mean,
yeah, it's easier to learn. No new frames.
Yeah, I was always saying, authentication frames, now that web is deprecated, it's just a two-way packet exchange is pretty much useless. We could just remove it. And then now we use it for something useful.
Yeah, so they just put that in there.
That's really good.
Yeah. So, and after that, you can exchange all that data. And there's another thing coming to WPA3, which is really, really important. And I'm really into that because they now enforce protected management frames. So 11W is now enforced. And also for all of the clients, you need to support that. It's not like it's not like the optional flag is set. They also use the required flag is set.
Do you want to explain what it is and how it's useful for Wi-Fi security?
Oh, yeah. So basically, protected management frames means that the management frames themselves are at a certain stage after the client connected to the network and they generated the PTK and all the handshakes are through. Then we have cryptography in place, and the AP also encrypts the management frames it sends to the clients. So that causes the client to be able to not only decrypt the frames, of course he can do it, but he can also make sure that those frames are actually from that AP he's connected to. So the classic deauthentication attack, like going through a public crowd and just send random deauthentication frames to throw everyone off the network, that doesn't work anymore. Yeah. So this also helps with security because it not only prevents like those boring DOS attacks, but it also prevents us from throwing out a client from an AP and forcing it to connect to one of our APs. So or a rogue AP from an attacker's perspective. And this is also one of the main things that helped with the crack attack back then, because you were able to send frames to the clients and they would react to that. For example, you were able to send a channel switch announcement to a client, but you send it from a rogue AP. So, and the client changed the channel, and that leveraged some of the attacks back then. And so with 11W in place, you can work around that. You're not able to throw out the client of the network anymore if you're not the AP itself.
So it's pretty much any management frames that are exchanged after the authentication and after the client has generated the encryption keys with the AP. So it's not going to be everything, the beacons and associations and all that. Yeah, it's going to be the frames that are exchanged afterwards, and it's usually the management frames sent by the AP to the client to do a specific action, like you said, change channel, disassociate, deauthenticate. And these frames are more like orders, right? When the AP sends it to the client, per the standard, the client has to comply with whatever the AP is sending. So like you say, it can be quite dangerous if someone else sends deauthentication frames, spoofing the MAC address of the AP. They could just disconnect people. And that could be, like you said, the first step into like a more serious attack, like a man-in-the-middle attack. So that's really good. The only issue we had in the field with that feature is that some clients would not support it. But now that they make it mandatory, I'm hoping it's going to fix that issue.
Yeah, and but there's one thing, because we still have legacy clients on our network, right?
Yeah.
And so how do we get those clients onto WPA3 networks? So because we still have our let's say one SSID, we don't want to add another, because that would force users to connect to another SSID. They would need to do something, and also maybe some people simply don't know, or most of the people don't know, that their device is WPA3 capable. So they would probably never change to that new SSID. So what they introduced is something called a transition mode, where you can simply run WPA3 SAE and WPA2 PSK on the same BSID. So, and what they do is they simply add both of the options to the robust security network element.
Okay. And then
so
the client is supposed to choose?
Yes, the client can choose in that, but we will get to that later, because that's an interesting point. Because clients should always prefer WPA3, right? And but it's still both offered and both done by the IP on the same BSID. Okay. And then there is another thing which is caused by the transition mode, and that is that those protective management frames are not anymore required, because you can do them. They are optional, but not required, because if they would be required, the older clients not supporting protective management frames, but supporting WPA2 only, they would not be able to connect to the network.
So I remember being when they announced the WPA3 certification, people were a little bit mad at this because they wanted the protective management frames feature to be mandatory. So I guess we have the reasoning behind why it's not mandatory and why it's only optional. It's because of the transition mode and because of legacy clients.
Well, it's required if you don't do transition mode. If you do a plain WPA3 network, it's required. So, but I have to say that the standard or the certification that came out by the Wi-Fi Alliance, this document, that's only 4 pages, and half of that is like explanation of boring stuff. So you have like basically 2 pages which describe all of that, and it's just like, you need to reference to that, you need to reference to this, and there's not really much in there. So it's
you get more technical information in the IEEE standards and the RFCs.
Yes, the RFCs are pretty good, and of course IEEE standards. Yes. I mean, it's an IEEE standard.
So do you think like vendors will find a clever way to implement this to try to steer WPA3 capable clients to a different SSID that's not into transition mode and enforce protected management frames?
Well, with with the SAE, if we do a PSK network, so we have it's going to be called pre-shared key network anyway, even with WPA3, because it's easier for people to remember that PSK is this password thing. And so with the transition mode with a PSK network, that probably won't happen in a decent manner, because the standard itself enforces this transition mode to be supported inside of the that they have both modes available in the RSN element. And so I think there is no real way to force a client into another SSID, because you would have to need, even though it's another BSSID, you would also have to have a different ESID, so the users also can see what's happening there. And I think this would cause problems, because as far as I know, there's no way to force a client onto another ESID.
So what we'll see in the field will be a lot of transition modes SSIDs.
Yeah, at least for some time. So because if you have a certain amount of clients with the with WPA3, you can turn off that that transition mode and run WPA3 network. So and maybe create a legacy network then for the older clients if you still have too much. So, but for the initial onboarding and migration to WPA3, that transition mode is probably quite a decent solution. And with PSK, the transition mode is also some kind of airtime savvy, because you only have that one BS ID.
Yeah.
And we will get to enhanced open later. There's also transition mode. So yeah, but I don't want to spoil that right now.
In terms of client support, have you seen a lot of a client already supporting SAE or WPA3 SAE?
Yes and no. With Windows 10, I installed the new 11AX chipset this week, and this caused me to update to Windows 1903.
Okay.
And because of the drivers, and I discovered that they actually rolled out WPA3 SAE with that. So you can use the latest version of Windows 10 to connect to that. Also on Linux, if you run the latest versions like kernel 5.1 and stuff, and the latest WPA supplicant, then you can also connect to an FAE network. But all those implementations are not perfect yet on Linux, because I think I talked to someone from Aruba short time after Security Field Day last year.
Yeah, when they presented it, huh? They did a demo.
Yeah, there was this guy called Mac, and he did the demo. And I talked to him. I met him in December when I was in Santa Clara. And I talked to him about his demo and about the implementation on Linux. And he told me that back then they had problems with the transition mode, actually.
Okay.
And so I don't know how the code is right now and what exact code they used back then, like in terms of version. But probably that should work better now.
Yeah. Okay. So just to give the listeners an idea in the timeline, today it's the end of May 2019. The certification got released end of last year.
Yes.
Or mid? Was it end of mid?
Mid or end? No.
Yeah, like June 2000. I have April 2018. So I guess it's been a year. But on the implementation side, we're not there yet, I guess.
I just pulled out these specification itself. The initial release in the document history says 9th of April 2018.
Okay.
So it's already 1 year old. Oh no, we need to implement it more.
Yeah, I was going to say we're slow. Huh? So that's hopefully we'll see. I don't know. I haven't looked into the the iOS and the Mac OS and the Apple ecosystem. I don't know if they support it yet. So that's for the client side of things. What about the on the manufacturer, the AP side of things? So you mentioned Aruba. Aruba is already supporting it. I know AeroHive is supporting it too because I've seen it. Do you know if any other vendors support it now? Is it widely spread out?
No, I think I have an Extreme Networks AP at work, but it still has no option for that. But it could be because that is also an 11AX AP, and it doesn't do all of the features right now. So that could also be it. But I think Aruba and AeroHive are, from my point of knowledge, the only vendors supporting it. Because, well, Aruba, they had a good start with that, because the guy that wrote all of the RFCs for WPA3, Dan Hawkins.
Yeah.
That guy actually works for Aruba, so
Okay.
they were faster, of course.
Yeah. Okay, so it makes sense. I'm expecting this year, like 2019, I'm expecting to see a lot more support for WPA3 throughout the different vendors.
Yes, me too.
You know, Cisco, Ruckus, all these guys, they should be very shortly, if not already. You know, they should support the feature soon in their new codes. So yeah, maybe it's going to take a little while for everything to get implemented, rolled out, controllers to get upgraded, and all of that. Yeah,
I think the Wi-Fi people's favorite phone, the Galaxy S10.
Yeah, right now.
It's actually the only phone I see on Twitter when someone tweets about Wi-Fi, like oh, I got a Galaxy S10. That one actually supports WPA3 already.
Oh, okay, awesome.
At least I've seen it mentioned in some articles, and I think I've seen screenshots.
So I have it. I just need a Aruba AP now.
Yeah.
Okay. I actually have. I have an AeroHave AP, but it's an AX AP as well, and I cannot use WPA3 on the AX AP because, like you said, it doesn't support all the features. So maybe one day I'll be able to do that, but.
Yeah, that's also another thing which is quite interesting to mention, because with all the major upgrades in Wi-Fi, you normally, for example, if you want to go to 11AX, you need new hardware.
Yeah,
and that was with all the major steps affecting layer 1 and layer 2. With all those major steps, you need to upgrade to new hardware. But with WPA3, you actually don't need to do that.
It's just a software.
It's just a software component. Yes.
Yeah.
Well, your client should have enough computing power, but
and something we should mention as well is WPA3 is not part of the new security advancement. They're not part of AX. It's like two different enhancements that are happening at the same time, but it's they're separate.
Yes, they're separate, and we'll probably see them together.
Yeah, because they're being rolled out at the same time. So people will probably think it's the same, but it's actually not the same. So
at this point, probably it could happen. For example, there was a long discussion about when to use a 2 or 3 radio AP with one radio dedicated to 11AX clients.
Yeah.
So and this could be a point where the vendors could actually move the 11AX clients to the 11AX radio, and then start only doing WPA3 at that point, and hoping that the client actually supports WPA3, or else it would be downgraded to 11AC. So or an 11AX radio where the client is able to.
Well, that's a good idea, because
that could be a point where you can steer that. Well, the problem is with that, it's not connected. You cannot guarantee that the clients come out with WPA3 and 11AX in place, but it could be a start to detect that. So, like having an 11AX radio out there with transition mode, let the clients connect, and then look like, oh, there's an 11AX client. It does WPA3. Let's move it to another radio. That could actually work.
Yeah, so I think WPA3 will be supported by most, new AX clients, especially if it's a phone, laptop, and so on. But the only, devices I'm worried about will be more the IoT devices. I don't know how much work it is to implement WPA3 and how expensive it will be for these companies, right?
Yeah.
So I don't know. I guess we'll see, because AX is big for IoT devices as well. It's a big enhancement.
It's also expensive. Like, for example, if you look at the IoT chipsets, they all do 11N, because it was the state of the art when they got developed, and they still use 11N on 2.4 gigahertz only, because no one ever cared to go to 5 gigahertz because it's expensive.
Yeah.
You need to redo all of the designs and stuff, and
Well, future will tell.
Yeah. So,
okay, so
let's go to the next enhancement in WPA3, and that's WPA2 Enterprise.
Yeah. So
and
just to summarize, SAE is pretty much the enhancement of WPA2 personal, and then WPA3 Enterprise, the one we're going to talk about right now, is the enhancement of WPA2 Enterprise.
Yes. So what they did with that is they introduced stronger cryptography. So they've enforced now an AES 256. 265 numbers, and which and some other stuff which causes something called 192-bit cryptography. So, and this is actually state of the art and pretty strong. But that's only half of the cake. So the other thing is what they will introduce is something called the modus, where you have the something called the CNSA cipher suite B in place, which is actually a smaller group of ciphers and ways to crypt the traffic, which is also licensed by like the government. So if you run a network for the government, you will probably need to enable this cipher suite B on your network.
Okay.
Because it's like I think you can compare it to what is it called, FIPS mode, or
okay.
Yeah, you can compare it to that.
So we're still using AES, and we're just using longer keys.
Yeah.
Okay.
So the problem with that is actually it's not really described in the standard itself or in the specification. So it's hard to find information on that. So, but what you can find is that it supports stronger cryptography. And what I also found out is that if you enable the cipher suite B on your network, you're not able to do any cryptography else. Okay. So that's all mutually exclusive. Either you run cipher suite B or you run everything else on your network. So, and because of this, the standing of that, so you don't want to have your government network running with some old crypto and some cipher suite B. So I think that's a security thing. It would be possible to run both on the same hardware, but it's something they created to secure the network. So,
okay.
Yeah. And with that in place, there's also another thing which you need to look at, because if you have a WPA3 Enterprise network, you have a radio server in the background.
Yeah.
And you cannot use the radio server with like any WPA3 Enterprise network. So they, in RFC 7268, they introduced some special radius attributes to that the network and the radio server can use to signal each other that they are actually running CNSA suite B on that.
Okay. So you need a radio server that would support it. That's what you're saying, right?
Yes, that's also the point, that the radio server needs to support that.
Okay.
And yeah, and regardless of this suite B, which is there's something else which applies to anything of WPA3 Enterprise, which is like they added some more tests for clients to actually validate the radio server certificate and do certificate pinning.
Okay.
Because you were able to ignore that with WPA2 Enterprise, which was pretty common on Android, I think, because you need to complicatedly install the certificate. And so they added something to that to make that a bit better and stronger.
That's really good. Yeah, that's really good, because it's always, the thing with the with WPA2 Enterprise, I guess it's more the implementation, the configuration of it. And like you said, if you don't do it properly, you can actually introduce more security breach. You can create more harm than what you're trying to achieve. Yeah,
and that's the point. And also with WPA3 Enterprise, they also introduce those protector management frames. Well, of course they do. Yeah, but what I haven't found for WPA3 Enterprise is a transition mode. So it looked hours. I didn't find anything that showed how to make this work, to transition your corporate SSID to WPA3 Enterprise in an easy way and still support legacy clients. So I think I need to spend some time at the lab to try that.
Have you been able to test in the lab the WPA3 Enterprise?
I haven't done testing on that yet because I was lacking WPA3 clients, so I wasn't able to do that. But I think when I'm back home, I'm at my parents' house right now. Then I will upgrade my home network to WPA3 and then try to do some tests with that.
Do you think like which Radius server do you use? Do you use like Free Radius or ClearPass or anything like that?
Probably for my testing, I will use ClearPass because it's easier for me to set up because I do that all of the day. Yeah. And on the other hand, I think Free Radios would be the way to go for all of that, but it's complicated as hell to set this up because
Free Radios is nice for easy tests, but as soon as you want to do something more complex, it's harder to get support as well and help. Yeah.
If you have really good people, you can run your network on Free Radios. For example, the university I used to work for, we have a woman there, and she's really, really into radios, like the protocol itself. She has no idea of how Wi-Fi works, and she says this, but she still says, I'm really good with radios. And she wrote a whole configuration for Free Radios for the whole campus network. And it's like, wow, oh my God, I wouldn't be able to do that.
Yeah, that's impressive. That's impressive. Yeah, wow. Well, I think ClearPass is based on Free Radios, right?
Yeah, it is. It is.
So
but don't ask me which version.
Oh my! One day I worked on a project where we implemented the IPSIM with the Free Radios.
Oh, okay.
Yeah, and I know I had some issues, and but they have a Free Radios. They have like a mailing list you can subscribe to, and then you can ask questions. It's kind of like a support group, and I was able to get help from one of the guy that's handle the support group. So I eventually made it happen. Talking about that project, I remember ordering the SIM card from Germany, because you can order SIM cards that you can program.
Yeah.
To do your testing and it's handled by a German company. So fun fact, really related to Germany, I guess. All right. So going back to our subject, so we talked about WPA3 SAE, WPA3 Enterprise, and that's what's under the WPA3 certification program. So like you said, you guys can go on the Wi-Fi Alliance website, download the specification sheets. It's not very long. Like you said, it's like 4 pages. It doesn't give you the full technical details, but I guess you can understand how they broke everything down to different sections, so different certification programs. Those are nice, but they don't take care of our open networks.
Yeah. Open networks are the other thing. Like I mentioned in the beginning, if you have a coffee shop and you write down your password somewhere, that's one way to go. But normally an open network is something you don't want anyone to type password in to get onto that. So like with the Wi-Fi project, I started with Wi-Fi, this IceFunc project.
Yeah.
There is only an open network. You want everyone to be able to connect. And back then we already started thinking about what can we do to secure the traffic of the people in the air, to just simply make it secure. And there was no way to find it, because with all the ways in place, there is nothing. You need people to know the password, and so or to explain them how to set that up. And so we decided to leave it open. But now there is something introduced by the Wi-Fi Alliance that is called Enhanced Open, or OWE, which is translated to Opportunistic Wireless Encryption. And basically what it is an RFC. It's RFC 8110, and that includes a way a client can connect to a network, like an open network, without a password. And during that, they start the connection, they will generate a password by themselves and exchange those secrets. So with nothing in exchange before, we can generate a strong cryptography in the air. So, well, it's what they actually do is a Diffie-Hellman key exchange, for those of you who know. And that's a good thing, but there's also some downside of that, because there is no real verification of the client, or there is no real authentication, because it's still an open network. You connect and you're in.
So there's just encryption, there's no authentication, just encryptions.
Yes, it's just encryption in the air. So this this allows us to simply run a man-in-the-middle attack. So we can simply set up another AP with the same SSID and hope that the clients will connect to our AP, and then we can simply sniff the traffic. So it's not secure against that, but if you run an open network, you still have the same problem. So if you want to mitigate man-in-the-middle attacks, you would need to use a different way of crypto in your network. So, but for coffee shops, it's quite nice.
For any public networks, it's actually quite nice.
Not only coffee shops, but that's the common example.
Yeah. Coffee shops, hotels, airport, convention centers, stadiums, you name it.
Yeah.
Just to, I think, correct me if I'm wrong, but I think to do the Diffie-Hellman exchange, they're leveraging the authentication frames again, right?
No, actually they don't.
Okay.
So what's happening? That's the other thing. They don't leverage the authentication frames at this point, because there is no authentication happening.
Oh yeah, makes sense. So it's happening after the association?
No. What they're doing is, after the probing and the response, they do the normal open authentication exchange, and after that they have the association frames. Okay. And they simply piggyback those Diffie-Hellman parameters onto those association frames.
Oh, okay. Awesome. Okay, makes sense.
And so what they do is they simply exchange 2 packets with their Diffie-Hellman parameters.
Yeah.
And after that, they do a normal 4-way handshake.
Okay. So we'll start to see 4-way handshakes on public networks.
Yes, we will definitely see that. So and how that works with Diffie-Hellman is like, for example, you can the easiest way to explain that is with colors. Okay. You have Alice and Bob and Eve, like that. Those are in cryptography. You have like those 3 parties, Alice and Bob, and they want to communicate with each other. And third party is Eve, like the eavesdropper, and that eavesdropper wants to read the communication between Alice and Bob. So how can Alice and Bob exchange a secret without Eve being able to decrypt the data, or to start anything with the data Eve can receive on this public channel? And so Alice and Bob have a common color, and they know what common color they have. Like that's, for example, that's a elliptic curve. So they agree on an elliptic curve. Then they generate their secret color. For example, Alice has blue and Bob has red. And then that's their secret. They won't exchange it. Then they mix their colors together. So Bob mixes red and yellow, and Alice blue and yellow. And then we have their, like, it's like a public color.
Yeah.
And with that public color, that's the problem with this explanation. You can guess if you have the common color and you have the public color, you can guess what color was used to mix that. But with elliptic curve cryptography, you cannot reverse that operation.
Yeah.
So that's the only difference where the actual Diffie-Hellman gets secure, and and then they exchange their public colors and mix it again with their own color. And if you have a starting color and mix it first with color A and then with color B, or mix it first with color B and then with color A, you get that. You still get that common color in the end, which is again secret.
Yeah, the Diffie-Hellman is not. It's widely used in security. In networks, for instance, we use it for VPNs. It just allows us to, encrypt data without it changing anything prior to the Diffie-Hellman exchange. I guess we can explain it that way.
Well, it's new to Wi-Fi, so...
yeah, it's new to Wi-Fi, I guess.
Finally, some Diffie-Hellman in Wi-Fi.
So it's nice for public networks because, obviously the clients and the APs, they're just, they won't have you don't configure anything on the client, right? Just the open network. So Diffie-Hellman is the easy way, just with 2 frames, to set up that level of encryption. Like you said, it's still not, it doesn't protect you against man in the middle, but at least it implements some sort of encryption. So if people randomly listen to the channel, they won't be able to see the data frames.
Yes. So, and the other thing that you already guessed, which is coming with OWE.
Transition mode?
Yes, transition mode. But this time, they do it differently. This time, they actually run 2 different BSS.
Yeah, 2 different SSID then.
Yeah. No, actually, it's only 2 different BSIDs. The ESID is, well, it's not the same, because you cannot say that, because it's how that transition mode works. Inside of the beacon frames and the probe response frames, there is an OWE transition element. Okay. And this includes the BSID of the OWE network and the channel and the band. So we could actually use the OWE transition mode to roam clients to a different band or AP.
Or radio.
Yeah, or radio. So because we have the information of the channel and the band in there and the BSID, but I guess this won't be used. Maybe some vendor will use it, but I think it will all stay on the same radio, and they won't use it for experiments with roaming and band steering.
And then it's tough to predict when we'll start to widely use OWE, right? Because in public networks you want to welcome everyone. Yes,
that's true. And so the client will connect, and if client doesn't know an element inside of the beacon frame, then it will simply ignore it.
Yeah.
And this but if the client is actually OWE capable, it will see, there's a transition element. Let's go to that other BSID.
Yeah.
And this is actually quite nice, because we can simply onboard every client to OWE if it's capable. The user has to do nothing. And the other thing, which is why I said that there are no different ESIDs, is because that in the transition mode, when you start that, you have the open BSS, and the open BSS will transmit its ESID. And with the OWE BSS, you won't have that. The ESID field inside will be empty, so it will be like hidden SSID.
Okay.
But it's recommended, or could you say recommended? It's enforced. If you turn off this transition mode and go to full OWE, you keep that SSID.
Okay, and I think the Aruba demo that during the Mobility Field Day presentation.
I think they did that.
Yeah, so I'm gonna link that video in the show notes as well if you guys.
That video. That video is really awesome.
Yeah, and they do a live demo, and they look at frames, and they let the delegate do some packet captures as well? And
Yes, yeah, right. I think I have a packet capture somewhere from that OWE demo.
Okay, awesome. So maybe if you can send it to me too, we can add it to the.
I think Rowell did.
Rowell did too. So I'll stay with him.
Yeah, or I can send you mine too. But I think it's just his packet capture. So, and you also need the latest version of Wireshark. So maybe you need to go into some beta release.
Or maybe I'll just do I'll open it and take screenshots and then add those images to the show notes.
Yeah,
makes more sense.
And also with the transition mode, there's another thing coming. Regardless of those protected management frames, this transition mode is actually required. So if you have a system which is running enhanced open, or which is able to run enhanced open, then you should not be allowed to create an open SSID without the transition mode.
Okay.
So that is actually enforced. So, for example, if you take the AP, create an open SSID, the standard is to send out the transition mode. But I think that the vendors will implement it in a way that this will not be the case.
Okay.
I think it will be able to run an open network without transition mode. But I don't know why you want to do that, but I think it's possible to turn that off. At least with the implementation from Aruba, that's possible, I think.
So in order for a client to support enhanced open, do they need OWE, I should say, do they need new hardware, or is it also just the software?
It's also just software.
Okay.
Like they just need the driver update.
Okay.
For the chipsets, and so that's also software updatable. But the main problem with OWE is not on the technical side; it's on the Wi-Fi Alliance side, because they didn't bring OWE into WPA3. It's not part of that, so it's a different certification. And as we know, with different certifications, which are not that big, it tends to happen that those don't get implemented.
Yeah.
And at this point, I'm really happy that Aruba actually implemented it, because from the beginning they said, we want OWE in WPA3. And the Wi-Fi Alliance was like, no, we won't do that. And then Aruba said, okay, we're going to implement it anyway. Because, they can do it. But what this creates is on the market, is a need for enhanced open. So other vendors will be at a customer, and the customer will ask, do you support enhanced open? And the vendor will say, oh, no, we don't. And they will say, yeah, but Aruba does it. Why don't you do it? And they're like, damn. And so this somehow forces the whole market to implement enhanced open. If, for example, or if Cisco would implement something else, everyone else would try to get that feature, because you need to be somehow competitive. And so that's why I'm really happy that actually Aruba introduced OWE in their software at the same point as they introduced WPA3.
Yeah. All right. So let's see if the other vendors follow. That would be nice.
And there's another thing with the whole of WPA3, because right now we have the WPA2 PSK networks, and we talked about PPSK or MPSK or DUN PSK in the beginning of the episode, and that was for a reason, because if you look at SAE and WPA3 personal, that's not possible anymore, because with all those, let's call it XPSK, with all those implementations, at some point you need to guess what's actually happening. So, for example, Arrowhive, that's like the easiest way to explain it. They receive the MIC in the four-way handshake, and with that they can guess which key to use. But at that point, the Dragonfly handshake is already through.
Yeah.
So how to guess which key to use in the Dragonfly handshake? There is no way to do that because it includes the elliptic curve. It includes the random number. Yeah. So there is no way to actually guess that. So this XPSK with a normal WPA3 SAE implementation will die.
Okay. So, but it doesn't really matter since we have a solution for it with SAE.
Yeah. So, but SAE still is another thing where you only need the password, and if you have the password, you can still connect to the network. For example, if you compromise an IoT device and have the password, you're inside the network. You're not able to decrypt traffic from other clients, yes, but you're inside the network.
Okay.
And at that point, we need another way to, again, bring this security with the multiple PSKs to the customers. Because if they want to migrate from WPA2 to 3, and they say but we have this XPSK rolled out, and we need to find a way how to bring all those clients to the network again. And they like the solution and say why should we go to WPA3 where we only have one password if we could go to WPA2, stay at WPA2 where we can use many passwords. And at this point, there was Dan Hawkins from Aruba introduced something to the IEEE committee, which is called a password element in the authentication frame with SAE. So I linked this in the show notes, and there is actually a document where he proposes a way to add a password element to the whole exchange to make it able to bring this XPSK to SAE.
So maybe it will become a standard. That's
what
you're saying?
So this will hopefully become a standard. The only version I have of this document is a version from 2018, but where it's not said when it will come to the standard, and it also doesn't say whether it will be required to implement that. Okay. But that's probably the same thing with OWE. Let's hope Aruba implements it and the other vendors will also implement it.
Yeah.
But this is a really good way to work around that issue that you cannot guess anymore. But now you don't need to guess anymore because you have this password element. It's actually that's simply a secure hash of the password. And by secure, I mean really secure. And I think there's also some magic happening. And so you cannot guess the password with that. So there will be a way to still work with XPSK and SAE.
So even with that in place, I guess the only way to go around all this security will be social engineering.
Yes. So, but not actually, yeah, but that's only half of the cake, because yes, we can get into the network, but we cannot passively decrypt the traffic. Yeah. And that's the major enhancement in WPA3.
Yeah. Okay, awesome. All right. Okay, so thank you, Hendrik, for all the explanations on the new enhancement WPA3 and Enhanced Open. Just before we close with this episode, let's talk about the Dragon Blood attack that got described by Matthew in his paper a couple of months back. Do you want to talk a little bit about it and what it's related and how it will impact us in the field?
Yeah, sure. So like all of Matthew's papers, it had at first it was strong impact on the community, because everyone was like, oh my God, WPA3 is vulnerable and let's look into that.
Already?
And yeah, it came out and was at least for me, a lot of people asked me oh my God, there was an attack. Do you know something about that? And can you do something? And yeah, I looked into that. And also other people looked into that. Yes, there is an attack, but it's only applicable to WPA3 SAE. And his paper targets 5 different ways to attack that. The first one is downgrade attack against the transition mode. And what actually is happening, it forces clients into using WPA2, and then you can use the normal attacks like a dictionary attack on that WPA2. And actually, that's not really an attack against SAE itself, right?
Yeah.
Because you need this transition mode to bring to transition to WPA3, and actually that transition modes and the clients using that mode need to be able to downgrade, because you cannot do like a real cryptography mode pinning. That would be one way to work around that, because if you have a larger network and you have some areas where you already have, like on vendor A, you already have the transition mode running with SAE, and in other parts of the network you only have WPA2, then the clients need to be able to connect to that old network. And so they actually need to be able to be downgradable with that SSID. And so the only way to mitigate this issue would be to use separate ESSIDs for WPA2 and WPA3, but you would lose your transition mode. Yeah. The second thing he found was a security group downgrade attack. And what's happening in there is that the initiator of this Dragonfly handshake sends in his commit message a cipher group to use for the cryptography. And what the attack includes is that they send declines of that security group back to the client with they spoof those frames and send declines to the client, and then force the client into using a low security cipher group. But even though it's possible, there is the Wi-Fi Alliance released a guidance for clients. So they only offer group with a decent cryptographic strength. So this should not happen if the client is implemented in a decent manner. So again, an implementation problem, if you want to say it that way. And then there are two quite interesting side channel attacks, which are quite similar. One is time-based and one is cache-based. And the time-based side channel attack basically is that SAE, when they use the point of the when they try to find a point on that elliptic curve, they do calculations. And while looping through the calculations, if you run arbitrary code on that targeted device, you can see how long it takes for the device to calculate and find a point on the curve. And with that information, you can use that to start a dictionary attack and make that dictionary attack easier. But there are two things. One is that you need to run actual code on the targeted device, and the other one is that it's only based on a bad implementation, because there are advisories that say that even though you found a point on your curve, it's recommended to keep calculating to a certain point with random values, simply to make it harder for side channel attacks, because all of the calculations for SAE, it doesn't matter how fast you have found the point on your curve. It always takes the same time for calculation. So there is a way to mitigate also that. And the cache-based side channel attack is basically looking at the memory patterns, how the client accesses his memory on the device, and this also again requires code on the client. Well, it's possible with JavaScript, which is quite interesting, because JavaScript, but also this side channel attack is not really an issue, because if you find a way to standardize those access patterns into your memory, You can try to make them all look the same, and then you can this side channel attack becomes not a problem anymore. And the last thing he found was a denial of service attack, and that thing is actually the only thing from that Dragonblood attack that is causing problems. And what they did is they found a way to bypass the anti-clogging mechanism in SAE. And this mechanism is something like a token-based thing where they start to try to rate limit commit messages from clients, because every commit message needs to be answered, and that takes this cryptographic calculation causes high loads on the AP. And to mitigate that, there is an anti-clogging mechanism in place, but they found a way to work around that and actually DOS some of the APs with only 12 frames per second.
Wow.
And so this actually could be improved, but because that's actually in the standard, the anti-clogging mechanism is not strong enough, it seems. Okay. But they will probably introduce features that help against that. So you can do on your vendor side. I think I read the statement from Aruba on that attack.
Okay.
And they already have something in place in addition to that anti-clogging mechanism to prevent those DOS attacks. But it will still be interesting to run those attacks in, I think, 2 or 3 years. Let's just try and run those attacks then. Let's just see how good that works.
Yeah. Okay. So from what I'm understanding, is most of it is just it's not the actual protocol or the cryptography that's broken. It's more the implementation of it. So as long as the vendors implement it correctly, we should be okay.
Yeah. And like there are Cs that actually describe when you should implement a should or must not, and but if vendors implement everything and not only do the required parts, then I don't see a large problem for WPA3 and its security.
Okay, awesome. Okay, and then we'll link the the actual paper that the Dragonblood paper that they wrote. It's available online for free. So if you guys want to know more, if you want to know the details on the the value exchange, the packet exchange, the math behind it, you can go. They even provide the code. So if you want to test it for yourself, you can do that.
Yeah.
All right, Hendrik. So thank you very much. Thank you for this overview.
Thank you for having me.
Yeah, no problem. Where can people find you online?
Well, online you can find me on Twitter. The username is Delta Oscar 9 X-Ray Echo DO9XE. It's just my ham radio call sign.
Okay.
That's where I started RF.
Awesome.
And so that's on Twitter, and then I think you will probably link my blog somewhere.
Yeah, I'll link your blog. Yeah.
Like for those who don't want to look in the show notes, it's linux-nerds.de. Most of that is in English, but also some German. I was a bit lazy and was writing in German.
No problem. Yeah, I'll link those in the show notes, and then when we publish, I'll also link your Twitter. I'll just CC your Twitter when we publish, so people can start following you on Twitter as well.
Yeah. Okay. Nice.
All right. Thank you very much, Hendriks.
Thank you.
Thank you guys for listening, and then we'll hope to see you back in the next episode. Bye-bye.
Bye.